Hi, welcome back to another episode of Kicked Up Chemistry with Professor Leonard. And thanks for joining me today. We're going to look at some volumetric glassware, which means ways that we can measure out liquids. Now, I'm just going to use water today, so I can go ahead and get rid of my goggles. But again, whenever you're in the laboratory, you always want to make sure you have your goggles on. Everything's a chemical. Water is a chemical. But if you were to get something in your eye, what do? You wash it out with water. So since it's water, we're not going to have to worry about wearing our goggles today. So the first thing I have are 3 different beakers. So I got the small little 10 milliliter beaker, a little larger 50 milliliter beaker, and then this tall form beaker, often called a Berzelius beaker. And beakers are very, very approximate. This one has about 120 milliliters in there, but that might be anywhere from 110 to 130 milliliters depending on the manufacturer. The markings on it are very, very approximate. So if we want a more precise value, what we would do is we would use a graduated cylinder. Now, sometimes I call this a smart cylinder. Why would you call it a smart cylinder? Well, think about it. It's graduated! Okay. So because it's kicked up chemistry, I like to kick it up a little bit, make it a little bit larger. So I've got a larger graduated cylinder as well. Now, whenever you're using volumetric glassware, what you have to do is measure to the bottom of what is called the meniscus. The meniscus is an upside down bubble here where the top of the liquid in your volumetric glassware kind of sticks or adheres to the sides of the container, and it kind of walks up the container. So we want to measure to the bottom of the meniscus. Now, also, typically on volumetric glassware, it's kind of a little harder to see on these, but the major markings are longer lines on there. This one you can see a little bit easier, so we've got some colored water in there, and you can see where those major markings have a little longer line. And so this one, if we look, there's 55, there's 60. It's more than 57, but less than 58. So we have to interpolate between the 57 and the 58. I would call it about 57.8 milliliters for the proper number of significant digits for that. So we always measure to the bottom of the meniscus. Now, of course, we skipped the most basic of all the different laboratory glassware that we're going to be using, the ubiquitous test tube. So test tubes come in all various different sizes and for different functions, how large of a test tube that you're going to need. So this is our standard size test tube. And then there is our kicked up, because it is kicked up chemistry, extra large test tube. Normal test tube, kicked up test tube. And later on I will be making a video. I have a whole lot of different video ideas, and we'll be using this in one of those videos that will be coming up. Now, another really common piece of laboratory equipment is the Erlenmeyer flask. So there is the 25 milliliter Erlenmeyer flask. Typically, chemical reactions are going to be taking place in a flask like this. So it's wider at the bottom, narrow at the top, so it's called an Erlenmeyer flask. Here's the 50 milliliter Erlenmeyer flask. And then, of course, we need the kicked up 4-liter Erlenmeyer flask for when you really need to make a large solution. Now, you might notice on this one that it also has a little sidearm coming off to the side. We can use this as a vacuum flask also for vacuum filtering different substances. So there's a big funnel that sits on the top there with a vacuum plate. You hook the vacuum hose onto the side, and it will pull any liquid through there, helping to dry your filtrate a little bit quicker. Now, another type of flask that we have is called the volumetric flask. The volumetric flask is a very, very precise instrument. It says on here 50 milliliters plus or minus 0.10 milliliter or TC, which means to contain at 20 degrees Celsius. And so when the meniscus is right on that white line right there, the bottom of the meniscus is on that line, that is exactly 50.0 milliliters of solution. So you can make very precise concentrations of solutions. Some of them have little snap tops on them. This one is a ground glass, so there's a small little ground glass stopper that goes into there. Now we have other various types of containers. This is a screw top vial, a plastic one. Here we have a glass screw top vial. Often these are called reaction vials because chemical reactions will take place into there. And then we have a smaller one as well. So these are just to hold different things that you want to keep track of, or as a reaction. This one is actually a Teflon coated on the inside of the cap, so that way you can have a chemical reaction and it doesn't react with the vessel or the vial in this case. Now, these are called disposable pipettes. Often they are called barrel, B-E-R-A-L pipettes, and they're transfer pipettes. So for instance, if I wanted to transfer some of my liquid over here into this 10 milliliter beaker, you simply squeeze the bulb, you release it, and then you can squirt it right into there. Here's another type. This one has markings on there. Again, they're very, very approximate. But if you wanted to add 1 milliliter, you can squeeze it down and add 1 milliliter at a time of the liquid. Or actually, these ones are marked off as 0.1 milliliters. Again, very approximate. If you wanted a precise amount, what you would use is you would use a pipette. So this one is a graduated pipette. It has different markings on there. There are also volumetric pipettes where it will only measure a distinct amount, very similar to the volumetric flask. I don't have any of those handy. So there are various ways of filling the pipette. And again, they come in all different sizes. This one is actually a 2 milliliter graduated pipette. So it's very, very small. This one is a 10 milliliter graduated pipette. It actually has two sets of markings. Down here, it has a 9, so that little bit at the end would be 1 milliliter. It also has a 1 on there. So going from this way, it goes from 0 to 9. Going from this way, it goes from 10 down to 0. And what you do to use the pipette bulb is you attach it to the pipette. You don't want to shove it all the way on there. You just want it on there tight enough where it stays. There are 3 different check valves. The one at the top says A for aspirate, S for suction, and E for empty or evacuate. So when you squeeze the check valve, it opens it up to the outside air. You release the check ball, and it stays squished in like that, which it now has a vacuum. And so now if I put it into my vial where I want to transfer some of my green colored water, you don't want to push it all the way down to the bottom, because what will happen is it pushes against the bottom and it doesn't pull up into the pipette very well. So you want to hold it a little bit above, and I'm going to put in 5 milliliters of my solution. So I'm going to go a little bit past the 5, and then I'm going to use the E or empty until I drop it down so the bottom of the meniscus is right on that 5. Now if you go too far down, not a big deal. You just hit the S and suction it back up again. Put it over into your beaker. Press E for empty. And you may notice that there's a small little drip still at the end. Now don't blow that drip out. This is TD, to deliver. So the volumetric flask said TC, to contain. This one says TD, to deliver. So it's designed to have that little drop left in there. So make sure you don't blow that little drop out. Now some other things that you may use to hold liquids or transfer liquids or see a chemical reaction. We have the syringe. So we can pull up a certain amount of solution. Again, fairly approximate pretty precise on this one, but they're still approximate measurements compared to a pipette. And then I have two different types of reaction plates. So these typically are going to be used to see if you have a chemical reaction or to hold small little amounts of, say, for instance, a dye. One of the labs that is typical in introductory chemistry is thin layer chromatography, or TLC. You can put your different dyes in the disposable plate here, and then when you use the capillary tube to spot your plate, it doesn't get all over and you don't cross-contaminate. Also, another common lab that is done in introductory chemistry are precipitation reactions. In a precipitation reaction, you're going to take two different solutions and you're going to combine those two different solutions together in a microwell plate. This one is a 24 well plate, goes 6 across, 4 down. There are 96 microwell plates, so the wells are much, much smaller because it doesn't take a whole lot, just a drop of each solution. So we don't want to cross-contaminate. So I'm going to take a couple of drops of this one using a clean pipette, hence that's why they're disposable. Put a couple drops in there, and then you can see whether or not a reaction is taking place. And in this case, no. When I mix the two together, there's no reaction. Which reminds me of a nice joke. I told a joke in chemistry class. I got no reaction. Of course, the wash bottle. So the wash bottle is for pouring out or rinsing off different apparatus. So for instance, after you use your beaker, or if you have some solution in your beaker or some solid in your beaker there, you may want to take it and rinse it out a little bit. So a good way to do that, if you had some solid stuck in there, is you simply put it that way. You take your wash bottle and you squirt out what's in there and you rinse it into typically a filter. And we will cover filtering in a different video. Well, if you hopefully that you learned something about volumetric glassware today. There's also a funnel. If you did, please continue watching these series of videos. Our next series, our next video is going to be on electronic devices, for instance, like these ovens that I have sitting here, the electric hot plate, magnetic stirrer, a couple of other apparatuses that you may plug in. And I have a lot of different demonstrations also planned throughout that I'll be uploading as well. So please like and subscribe. Click that like button on the video. Click subscribe so that way when I make those new videos using, for instance, the supersized test tube, then you'll get notified and you'll be able to watch that video as well. Thank you very much.